All right. In this lesson, this is comparing real numbers. This is chapter 1-10. Now, when we did 1-1, if you go back to that video on chapter 1-1, you will see where we went over the difference between natural numbers, whole numbers, and integers, rational numbers. Today, I'm going to piggyback off of that and include irrational numbers, but I won't be going through each of the previous rational number categories in this lesson. So what I'm going to do is simply talk about the difference between rational and irrational numbers, so you can get an idea. But if you want it broken down, please go back to chapter 1-1. All right, so rational numbers are, let me get my pen here so we can get this right. Rational numbers these are numbers that are natural. If you remember, natural numbers start from 1, 1, 2, 3, 4, 5, on and on and on. These are whole numbers. Whole numbers start from 0, 0, 1, 2, 3, 4, 5, on and on and on. Integers. Integers are your positive and negative whole numbers, or positive and negative integers, which is -3, -2, -1, 0, 1, 2, 3, all those numbers like that. And they also include your fractions. They also include your decimals. They also include your percents, like that. So you can have 5.5 as a mixed number, or 8/7 as an improper, 0.2 as a decimal, 1.1 as a decimal, 15% as a percent. All of those are rational numbers. So, and all of those are under the category of real. Now, irrational numbers are also real. So I guess we have an entire heading here of real numbers. Okay. So now let me tell you what an irrational number is. It is also a real number. But it also includes some numbers that's not natural, whole, integers, fractions, decimals, percents, anything like that. It's not that. So an irrational number would be a number that's not rational, which are numbers like this. Pi. Pi, as we know, is approximately 3.14, but it doesn't end there. It is a number that never ends and never repeats. 3.14 is just the beginning of it. So pi does not equal 3.14, but it is approximately 3.14. All right. So pi is an irrational number because it never ends and it never repeats the pattern. Also, square root of 3. Square root of 3 is a non-perfect square. The square root of 4, I'm going to put that up here. The square root of 4 is rational because that equals 2, okay, which is rational. But the square root of 3 is a number that never ends and never repeats when you put in your calculator. So all non-perfect squares are irrational because they never end and they never repeat, just like pi. All right. Also, a number that never ends and never repeats, other than non-perfect squares and pi, is a number that might look like this: 1.2479835545612 ... Lots of dots. Why? The number never ends and it never repeats. Now, when I say never repeats, I know you see the number 5 in there several times. I know you see the number 4 in there more than once. So when we say never repeat, we're talking about a pattern. You do not see a pattern in here. When you don't see a pattern and the numbers that you see do not end, it is irrational. For instance, in this example, do you know what number is going to come next? If you don't see a pattern, you do not know what number is going to come next, chances are it's irrational. Okay. But a number like 0.18181818 ... you know what's coming next? 18, right? That's rational. That's rational. If you see a pattern, even though it never ends, it's rational. All right. All right. So all of those are under the heading of real numbers. So now, in this lesson, you got to be able to identify what number is greater than another number. So let me draw a line here and separate the two. All right. So let's take an example like the square root of 7. And I want to know if that's greater, less than, or equal to 2 2/3. All right. So what we have to do is get both of these numbers in the same format. Like, I don't know what the square root of 7 is exactly, right? So what we have to do is we can use our calculator in this case because I need to be pretty close. So when I get the square root of 7, I get a number that says in my calculator 2.645. And then the numbers continue on and on. All right, so now I want to know if that's greater or less than 2 2/3. Well, watch this. 2 2/3 is a mixed number. I need to convert that to a decimal so I can compare. So when I convert that to a decimal, I take the 2/3 part and I convert it to a decimal. And now I see that that is going to be 2.6666. And 6 goes on forever, right? All right, so that's what this is. So now I compare these two numbers. Now it's pretty easy to compare. When you first start out, the 2 here and the 2 here are identical. It's a tie. All right, the 6 here and the 6 here, they're identical. It's still a tie. But look at the next digit here. I got a 4 here and I got a 6 here. There's a difference. Now we know which one's bigger. So 2.64 is less than 2.66. It doesn't matter what the rest of the digits are. I go one place value at a time. And when I get to the one that's different, I can determine which one's smaller and which one's larger. So in this case here, the square root of 7 is less than 2 2/3. All right, you see how that works? So convert it, everything to decimals, and then you can clearly see which one is greater or smaller. All right, let's look at this. Let's say I have 15.7%, and I want to know if that's greater, less than, or greater than, or equal to the square root of 0.02. All right, looking at it the way it is, I don't know. You really got to do the work to make sure you're looking at this correctly. So the first thing I know is that 15.7 as a percent, I got to take my decimal point and move it 2 places to the left in order to just have a decimal. So I'm going to have 0.157. That's how I convert my percent to a decimal. I move my decimal point 2 places to the left, which is the same as dividing by 100. Now I'm going to put my circle here and get the square root of 0.02, which I don't know what that is, right? So it's not a perfect square. So we put that in our calculator and we get this number here, 0.141421356, and there's some more numbers that my calculator cannot hold in there. But I got plenty of numbers. I don't need any more than that. All right, so now this number on the right is not bigger because you got more numbers. Keep that in mind. It's not bigger because you see more digits. You have to go by the place value. So let's do that. So first of all, I see I have a 0 here and a 0 here. It's a tie. I got 0.1 here, 0.1 here. It's still a tie. Now this is the number that's different. I got a 5 here and a 4 here. The rest of this here does not even matter because I can determine if 0.15 and 0.14, which one's bigger or smaller. Even this here, I don't even need the rest of that, and I don't even need that last digit. I can clearly see 0.15, 0.15 is greater than 0.14. It doesn't matter what the rest of the digits has. Okay, that's why we go one digit at a time. So don't make the mistake of saying, oh, the right side has more digits, it got to be greater. No, it all depends. It all depends. All right. All right. So 0.157 is greater than 0.141421356. Or should we say 15.7% is greater than the square root of 0.02. That's the correct way to say it. All right. All right. All right. All right. So that's it. You can see the rest of the questions in let's do one more. Let's do one more. This one here I really want to show you because you got to put these on a number line. And I do want to show you this. Okay. Here's my clear button. Let's look at this. If you have something that says let's clear that one more time here. Let's back up. All right, so let's do this. I'm trying to see. Yeah, looking for my eraser there. There we go. All right, I know I'll find it eventually. All right, so let's put some numbers in here. All right, so let's say we have the square root of 30, a 6, a 5 4/5, and a 5.36 repeating decimal. Make sure you can see that decimal there. All right, and the direction says put an order from least to greatest. So please pay attention because sometimes on these exams, they'll go greatest to least. And we're so used to seeing least to greatest, we write it incorrectly. So let's make sure that we read it. All right. All right. So let's look at it. What I need you to do in this case, on each one of these situations, is change them all to the same format so we can put everything in order. So let's look at the square root of 30. You're going to need your calculator for this. The square root of 30 is going to be 5.47. Okay. This number will stay a 6. This number will be a 5.8 when you convert the 4/5 to a decimal. And this is 5.36. And that's still repeating. They're all decimals now. Right? Now we can clearly see which one's the smallest number. And we could put this number. Let's go ahead and number it. The smallest number would be this one, 5.3. All right, that's number one. So let's write that one down here, 5.36. After that would be 5.4. This is number 2. So I'm going to write 5.47. And this one here looks like it's the next one at 5.8. That would be 5.8. And then the last digit here is the largest one number, which is 6. And that's in order from least to greatest. All right, so I wanted you to see that one because that one is one of the examples in your book. And that's how you can get to that answer very quickly and easily. All right, that's that.